Hello, everybody. Welcome to today's Delight Talk. We have two excellent talks lined up for you, as always. Uh, we have, okay, first up, we have Simran from Sanjeev's group, and she will present Instruct-SkillMix, a powerful pipeline for LLM instruction tuning. Let's welcome Simran.
Hi everyone, I'm Simran. I'm presenting Instruct-SkillMix in joint work with Simon Andrew Boyle. So to start off, we're going to talk about instruction. I'm sure most people are still familiar with it. But, you start off with a pre-trained model, and you want to fine-tune the model to be able to follow natural instructions and hopefully do well on. So usually for fine-tuning stages, you have supervised fine-tuning and then supervised fine-tuning, and then also that's followed by like something like RLHF or DPO. And for the sake of this talk, we're going to focus just on supervised fine-tuning. So a lot of companies don't really release their data, and there have been a lot of efforts towards creating open data sets. Human data is very costly, and even though it is higher quality, so there has been a shift towards generating synthetic data using strong models such as this is pretty scalable because it's semi-automated and it's also not as expensive. So some popular examples of these like synthetic data sets include like Alpaca and UltraChat. And the way that these are created are usually provide some in-context examples to use a powerful LLM to produce like thousands of question answer pairs and then use them for filtering. And within these data sets, usually longer integer responses do most of the work. So fine-tuning on these data sets usually falls short compared to the proprietary Instruct versions of the models. And so like, why might this be the case? One possible reason is that there is a lack of diverse data. And so maybe these like synthetic data sets are inherently of lower quality or some kind of lower diversity compared to human data. Another possible reason is there's uneven data quality within the data set. So work from earlier this year showed that fine-tuning on the 1,000 longest responses from data sets like might outperform fine-tuning on the entirety of the data set. So an open question is, can like synthetic instruction tuning data sets yield like comparable or superior results to what you see with the proprietary Instruct models? So one line of belief is that the source of a language model's capabilities comes from training, and the role of instruction tuning is to impart skills such as like question answering and helpfulness and all of that stuff. So we introduced Instruct-SkillMix as a way to generate high quality and diverse synthetic data to impart these skills. And we'll give some examples of like what these skills might look like in the next slide. So a high level overview work for our pipeline is we first have skill extraction, where we use some kind of powerful LLM to like kind of curate a list of instruction following skills. And then in the second step, which is data generation, we use random combinations of the skills that we have to create like question answer pairs that most combine the skills. Diving more into the skill extraction step, our initial attempt involved kind of utilizing open data sets. So we would just take like samples from these data sets and then extract like, a skill from each example. And then we use like cluster the skills that we curated. So here are some examples of skill clusters that were curated from Alpaca. Okay, so we have like data handling and management, content curation, presentation, and a bunch of other stuff as well. Alternatively, like this is the method that we settled upon just because we found it to be better. We can directly query a frontier model to be able to extract these skills from a list of like topics generated by that model. And here's some examples of those skills.
It looks like these skills are still like semantic in some way. They're not necessarily like instruction following skills in the way that you said in the beginning.
Right. I guess because I guess like the instruction following skills themselves might be kind of very high level or vague. So creating synthetic data without some kind of like fine grained maybe like topic related information or like some area or something like related to like I don't know like jewelry or like I guess this kind of allows for you to create better synthetic data. If you had something like helpfulness, creating a synthetic example of like helpfulness is it uninformative. Is that kind of question?
Yeah, I think so.
But were there were some skills, right? About
There's something like creative writing, like stuff like that.
Okay.
More by instruction policies.
It just reminds me of like in the previous skill mix that you had done, like you had semantic topics and then you also had like rhetoric devices or something like this, and you would kind of take like Cartesian products.
Yeah.
So here you're just taking these skills.
After we have the list of like skills that we've extracted, the second step of the pipeline is creating the synthetic data. So here is an example of like a Q&A pair that was created from these skills. And it's from the point of view of a high school English teacher who's trying to create or encourage her students to do some project on Shakespeare and use multimedia tools and like other stuff.
Yeah. So what are some of the techniques you use to encourage the generation of diverse skills, like for the first round? Like the second round certainly increases. Oh, by first round just means model generated. Yeah. So basically without the composition stuff.
Oh, just like for one skill?
Yeah, one skill. How is there a way that you qualitatively analyze the skills that were generated to make sure they cover enough breadth?
I think we just like looked through them. We didn't like quantitative.
Okay, that's cool. And they
coverage, how would you?
yeah, like make sure they cover enough like professions and stuff like
Within.
Yeah.
No, I think that is a wrong way to think about it. That
Okay.
I mean, you're just not trying to cover everything. You're just giving an example. It already knows all the professions.
But you're using the skills as like seeds to generate additional examples.
No, instruction tuning cannot work unless if there's out of training set generalization extensive. Anyway.
Yeah, so this is probably sufficient. Okay.
So to kind of answer why like this pipeline lead to more diverse data or higher quality data, one natural way to quantify data quality is the presence of more skills within like a given like fixed piece of text. And based on some theory from last year, like we can see that like the number of like k-tuples of skills scales as the number of skills to the k. And this might lead to like more diverse and higher quality queries. And we'll show that unlike an existing data set, like small subsets from Instruct-SkillMix data are not responsible for the final result. So now going into some results, we fine-tuned like Llama 3, 8B, Neutral 7B, and Gemma 9B on Instruct-SkillMix data, just 50,000 examples ranging from 2,000 to 4,000. And we can see that on Alpaca Eval 2.0 that the Instruct-SkillMix models outperform, like either match or outperform like the proprietary Instruct counterpart. So what might be responsible to this? So we run some ablations to look into how like different factors or different parts of our pipeline contribute to this better performance. So we first look into the benefits of skill extraction. So what happens if we don't mix any skills at all? What we do is we fine tune a model on various like subsets of P2K, which was like a previous effort for open instructions we can do that. And we can see that if we train on just like 1,000 examples of Instruct-SkillMix data, where there's no skill mixing, this does better than like a previous baseline where you just fine tune on like the 1,000 longest responses from Alpaca 52K. And we'll note that the skills that were extracted to create this data set, those actually come from Alpaca 52K directly. We also wanted to look into the role of mixing skills, and we find that mixing skills marginally increases performance for the SFT models, but the improvements like aren't, or the amount by which we see improvements isn't as large as what we see with just skill extraction.
So these terms are not SCD.
Oh yeah, so I can so in this table, like any of the pink numbers, those correspond to the performance of a model that was trained on Instruct-SkillMix data when the seeds were extracted from like seed data sets. And then the blue numbers correspond to numbers for Instruct-SkillMix data where there is no seed data set and the skills are directly like obtained from like prompting a frontier LLM.
What do you prompt there without the seed data?
Without the seed data,
Yeah.
effectively you just ask for like a list of like topics that like you might encounter in like a human with a model, and then from that list of topics, then you ask like, okay, like what skills might be involved for like questions or answers related to this topic.
But wasn't Alpaca created similarly?
They use like for Alpaca, they effectively just like they have a set of seed like in context like examples, and then they generate like those in context.
I think the seed examples were written by humans, like
Yeah.
300 or 400 seed examples.
It's better to not include humans.
That's right. Human bias.
Oh, and then one thing I wanted to highlight from this table is also you'll observe that like every single entry, like the blue number is usually higher than the pink number. And so that also points to the fact that like you can use skills like directly from the model instead of using any seed data set, that usually leads to a better like fine-tuning data set.
But didn't it say that the evaluation slate and the training slate are kind of different?
For Alpaca, for
Yeah.
Yeah. So in the evaluation set, they just curate like, or they collect a bunch of existing evaluation data sets, and use that as Alpaca. You don't have like the roots stuff, but then the fine-tuning data is generated with like the in context examples for human.
The point is, Alpaca skills are more limited.
Are these win rates computed by GPT-4?
Yeah.
And is the model which generated the synthetic data also GPT-4?
GPT-4 Turbo, but we have some experiments later to rule out like
That-
biases that might arise from the data generation model.
Yeah, because if I look at this, my take would be that your model just learns to imitate the style of GPT-4. If you don't provide any seeds, then it gets even closer to the distribution of what GPT-4 would output, and then GPT-4 seems to prefer its own output. And this would be one explanation for the comments. But you said you ruled that out.
Yeah.
Just wait a minute. Next slide, probably.
So the observations from like the past two slides indicate that the quality of like the synthetic data drives how well a frontier model can impart skills onto the model undergoing instruction tuning. So more specifically, we see that like a frontier model is a more effective teacher when it utilizes its own skills as part of the instruction, as opposed to when the skills come from existing data sets. And we also, the second observation that supports this is that incorporating these suboptimal skills from existing data sets as part of like the synthetic data set is still more effective than using a random number of examples from the existing data sets or even like the longest completions from those data sets. And we also wanted to rule out some confounding factors. So one question is, are the improvements that we observed just due to the use of a strong data generation model? And what we do is we rewrite the answers to Instruct-SkillMix with GPT-4 so that we can compare like how like performance differs between training on like Alpaca 1K longest and the Instruct-SkillMix data. And then we also rewrite the answers for the longest 1K examples in the Alpaca data set with GPT-4 Turbo. And you can see that for a fixed data generation model, that if you use like the Instruct-SkillMix and LC win rate is better than the LC win rate that you see for Alpaca 1K longest. And even still, like a strong data generation model still helps. And you can see that the gap between Instruct-SkillMix and Alpaca 1K longest is actually larger for when GPT-4 Turbo is the data generation model. We also wanted to rule out any bias that might arise from using the same, like models from the same family for data generation. So we also use Claude as a grader, and you can see that the one like Claude is actually usually more generous as a grader across the board, and the rankings of like the models across both graders are pretty consistent over here. And finally, we wanted to look into what makes like creating an instruction tuning data set so hard. We noticed that the qualitatively, the quality of the Instruct-SkillMix data was pretty uniform. And if you have data that's generated by humans, there might be some more variation. And well, usually companies like they have a lot of quality control measures and whatnot. And this associated quality control can be pretty expensive. So what we do is we replace 20% of like the examples in the Instruct-SkillMix data with basically just junk data, either like short responses, which is like the Simran Instruct-SkillMix, or junk like responses, which are long but like deliberately like unhelpful responses. And we can see that there is a pretty big drop in both the LC and raw win rates. And this is especially catastrophic for when you have Instruct-SkillMix in the seed and use like a seed data set to extract the skills instead of directly from prompting models. So here, like what makes making an instruction tuning data set so hard, we can see that even a small fraction of like low quality data can severely hurt performance over here.
The difference between.
Oh yeah, yeah. So here you can see that like if you have like Instruct-SkillMix that was generated with like the data set skills, you can see that if you include 20% of drunk data, the LC win rate actually drops to underneath 1%. Here, if you have like skills generated by the frontier model directly, the drop is about like 12%. But so it is still obviously a big drop, but it's not as severe as like what we see over here.
Also the length. The length doesn't drop. Average length.
Oh yeah, the average length.
So you have 5 minutes.
Okay. So to kind of just summarize everything we've discussed so far, we introduced Instruct-SkillMix as a way to generate high quality and diverse synthetic data for instruction tuning. And we show that that fine tuning on this data can lead to significant gains on Alpaca Eval 2.0. And we have some ablations to rule out confounding factors like the use of like a strong data generation model or the choice of the grader. And we also have some preliminary experiments that suggest possible reasons for why creating instruction tuning data sets via naive crowdsourcing could be